Hello everyone, so today we're going to be talking about inverse trig functions, which most closely goes with 14.2. And what inverse trig functions are is we are looking for the angle based on the given ratio. So with regular evaluating with trig functions, we would say, alright, hey, what's the sine of 30 degrees? For the inverse, we would instead say, okay, what's the inverse sine of 1/2, and then you would give me 30 degrees. So we're looking for the angle instead of the ratio. For arc sine and sine to the negative first, or inverse sine, they're both always going to be interchangeable, the arc sine versus sine to the negative first. And then we've got arc tangent and tangent to the negative first. So our quadrants for our range for these guys is the first and fourth quadrant. Reason being, we can get values that are both positive and negative, and in order to get a positive value for sine and tangent, first quadrant's good, and then in order to get a negative value, that would be in the fourth quadrant, because if we're looking at our ASTC idea, only cosine functions are negative here. So sine and tangent inverses are going to be on the pretty much right-hand side of our unit circle, and then inverse and arc cosine are going to be the top, because again, if I'm looking at my ASTC, cosine is negative here, so that'll be an easy spot that we're able to get negative values. So if we're looking at, we have our symbols, we have arc sine, inverse, our domain for sine and cosine is -1 to 1, because the highest x and y value we can get within the unit circle is 1 or -1, due to the fact that we have our radius. Like over here, we would have a cosine of -1, here we'd have a sine of -1, and then +1, +1. Tangent, and we'll see this more when we look at the graph, the domain's actually all real numbers. So we can actually take the inverse tangent of really anything and get an actual value. Now we would go within reason for the unit circle, because we're going to be doing it without the calculator, but in general you can do it for pretty much anything. And then our range, like we talked about within our quadrants, first and fourth for sine and tangent, and first and second for cosine. So that way we can get both positive and negative. So let's give this a shot. So we evaluate the expression in both radians and degrees. I like to think of this in terms of the trig hangive, just because instead of memorizing, I'd rather, have something I can go off of. So if I want the inverse sine of √3/2, I'm asking myself, what angle gives me a sine of √3/2? If we look at our hand, in order to get 3 fingers below, I've got to put down my index finger, which is 60 degrees, which in terms of radians is a pi/3. So that would be my answer for the inverse sine of √3/2. Now if we're looking at our tangent, inverse tangent of -1, I need to figure out, okay, which finger can I put down for tangent in order to get a value of -1? Well, let's look at the fact that it's 1 first. So if I put down my middle finger, I get that √2/√2, which is 1. So that would give me 45 degrees when I flip it back over. Because I want my value to be negative, I know that I need to put it in the fourth quadrant. So it would be a -45 degrees and a -pi/4, or if you prefer only looking at positive angles, -45 degrees would be 315, and just a little bit shy of 2 pi with the denominator of 4 would be 7 pi/4. I'm okay with either since they are coterminal. It's going to be a personal choice whether you prefer it to be all positive or if you're okay with seeing a negative. For our next one, we have the inverse cosine of -0.5, which of course we know is -1/2. So ask yourself, okay, what angle would give me a cosine of 1/2? And then we'll take care of the fact that it's negative. So if I put down my index finger, I do get that one finger above. So that's going to be our 60 degrees. Now, but we want it, since inverse cosine is in the top two quadrants, we want a 60-degree angle in here. I can't say negative 60 because that would bring me into the fourth quadrant where cosine is positive. So I need to talk about a 60-degree angle in here. So if we take our 180 minus 60, that gives me 120 degrees. And as a radian, we have a 60, so we know that that's a pi over 3. And a little bit shy of 1 full pi would be 2/3, since 2/3 is a little bit less than 1. So you do have to be careful where you can't just make it a negative angle for inverse cosine of negatives. Let's take a look at a quadrantal. So find the value of arc sine of -1, write the angle, and measure degrees and radians. So I want to know where sine is -1. Well, down here my y value is -1. So that would give me 270 degrees, or 3 pi over 2. If you wanted to say -90 and negative pi over 2, you could. It would be the same idea. Now the other type of problems that we might see in this section are kind of a dual step problem. So we're going to be looking at, in this one, we're going to take the arc sine of 1/2. So ask yourself, alright, what angle gives me a sine of 1/2? So one finger below. One finger below would be 30 degrees. So I want to take the cosine of 30. And if I take the regular cosine of 30, I just have root 3 over 2 from the trig hand jive, or if you chose to memorize all the values. So that's my answer. Let's look at another one like that. So if I'm taking the arctangent of negative root 3 over 3, so I'm thinking, okay, well, I had definitely rationalized, so I had to have 1 over the square root of 3. That was, if I flip my hand back over, 30 degrees. So, and I'm negative, so we're looking at like a negative 30 degrees, or just the 30 degrees in the fourth quadrant. So cosecant goes with sine. So my sine in the fourth quadrant, so negative value of 30 in the fourth quadrant, is 1/2 negative. And I want cosecant, so I'll flip that and get -2. We will do plenty of practice, particularly with these dual step ones. And let's look at 2 more. So instead of my inverse being on the inner function, it's going to be on the outside. So if I want to take the cosine of pi, cosine at pi, we're looking at over here. So that is -1, 0. Cosine is therefore that -1. So if I want the arctan of -1, which value gives me the 1? That would be the 45. Since I want it to be negative, I have -45 degrees and negative pi over 4, or if you prefer all positive, that 315, and that 7 pi over 4, since that would be a little bit less than 2 whole pi. And then one more. So if I want the sine of 5 pi over 3, that is in our fourth quadrant, so we are negative. My reference angle is 60 degrees. So my sine is going to give me a negative root 3 over 2. And I want the arc cosine of that. So, in order to get a negative, I know I have to be in this quadrant. So the cosine, the finger that I can put down to get 3 above, is 30 degrees. I need to put 30 degrees into quadrant 2. So 30 degrees off of the 180, so we can take 180 minus 30. We get 150 degrees, and with a 30 degree angle, we have a denominator of 6. So a little bit less than 1 full pi with a denominator of 6 is 5. Like I said, we will practice these, but just getting the basic, okay, what does this inverse thing mean for me, is going to be really beneficial. And really, we're just looking for the angle, and then we put it in the appropriate quadrant if we're a negative. So that's all for now, and I'll see you in class.